Hi guys, you are now here in Ask Teacher J, and for this video, we are going to discuss a problem related to theoretical yield. Okay, but before we proceed with the problem on theoretical yield, let us explain first what theoretical yield means. Okay, from the word yield, okay, the other word for yield is something that you get, right? Or something, or the amount that you get after doing something or doing a process. So basically, the word yield here actually refers to the products that we obtain after the chemical reaction happens. Okay, and more specifically, the amount of products that we get after the reaction, the theoretical yield, should actually be based on the limiting reactant. So let's try to write some information related to theoretical yield. Theoretical yield is the value of the amounts of products, okay? Amount of the products that we that is the more valuable to us. So depending on this one, if this is the more valuable product or this is the product of focus, then that will be the yield of Fe. And if you are focusing on CO2, then that will be the yield of CO2. So the amount of product obtained. Okay. The theoretical yield, from the word theoretical, is calculated value, or calculated, I think the right word is estimation from calculations. So it's an estimated value, okay, obtained via calculations. So when I say via calculations, then that is the process of stoichiometry. So we need to do stoichiometry to determine the theoretical yield. Last but not the least, and the most important thing, the theoretical yield should be based on the limiting reactant. So in your stoichiometry problems, if you are encountering, or if you have encountered a limiting reactant problem, the challenge is to look for the limiting reactant first, and once you know the limiting reactant, that will be the basis of your calculations for the rest of the determination of the amounts of products obtained after the reaction. So take note of that one. That is the theoretical yield. We have another word here, which is the actual yield. Actual yield is from the word actual, okay? It's still the product obtained, okay? They still have the same meaning in terms of the word yield, okay? Yield. But since there is the word actual, it means that the actual yield is the value of, or the amount of product obtained, okay, via experiments. So via actual experiments. Okay. Yeah. So that means the actual yield value is not determined via stoichiometry. You need to do the actual laboratory experiment to extract, to separate components just to get the product of focus that you want to obtain. Okay. So it's usually a given value, or if it's not given, there's actually a relationship between theoretical yield and actual yield. So there is a new quantity that I will introduce, or a new term that I will introduce, which is the percent yield. Actually, the percent yield is the ratio, or the proportion of the actual yield with respect to the theoretical yield. Theoretical yield. Okay. So that actually means how much of the expected yield is obtained in actual setting, or in actual experiment, times 100. Okay, so that is the challenge here. So we need to know, or we need to determine the percent yield based on the actual yield and theoretical yield. Okay, so we have this problem over here. Okay, I need to correct something because I think there's a mistake there. It's not 15, but it's 150. So we have here a theoretical yield problem. Okay, the problem states that imagine you are working on ways to improve the process by which iron ore containing Fe2O3 is converted into iron. So the chemical equation is Fe2O3 plus 3CO to form 2Fe plus 3CO2. The first question is, if you start with 150 grams of Fe2O3 as the limiting reactant, what is the theoretical yield of Fe? Okay, if you focus on the problem, it is already stated that Fe2O3 is the limiting reactant, and the amount of reactant consumed or used in the experiment is 150 grams. So of course, this is the first, or this amount will be entirely used up in the chemical equation, or sorry, in the chemical reaction. So that is why that will be our basis, because if we exhaust all 150 grams of Fe2O3, what is the expected amount or the yield of Fe that we're going to get at the end of the chemical reaction? Okay, so of course, we're going to do stoichiometry starting with the value of 150 grams of Fe2O3. Okay, so let's answer that one first. Okay, so let's go here at the bottom part. So our goal is to determine the theoretical yield of Fe. So our starting value is 150 grams of Fe2O3. Okay. Of course, in doing so, we need to convert, okay, that's always the process. Convert the grams of Fe2O3 to moles of Fe2O3. We need to do this because the jump or the conversion from Fe2O3 to Fe cannot be done in grams. We need to convert it into moles first. Okay. So in this one, we need to determine the molar mass of our Fe2O3, right? Because that's mole per gram. That's the units of the molar mass. The molar mass of Fe2O3, okay. You may pause this video if you want to solve on your own. Okay, the molar mass of Fe2O3 is 159.69 grams per mole. So I'm going to write that here. For every 1 mole, there is 159.69. Okay. After that, okay, cancel the units. And then we're going to convert the moles of Fe2O3 into moles of Fe because that's what we want. So to get the values that we're going to put here, we need to have a stoichiometric ratios. Okay. So the relationship between Fe2 and Fe2O3 and Fe is for every 1 Fe2O3, there are 2 moles of Fe. Okay, for every 1 mole of Fe2O3, there are 2 moles of Fe. Okay. And last but not the least, we are going to convert the moles of Fe to grams of Fe. Okay, I forgot to cancel the units. Okay, this one is the molar mass of Fe. Okay, pause the video if you want to determine the molar mass of Fe by yourself. Okay, so the molar mass is 55.85 grams per mole. So this one, for every 1 mole of Fe, we have 55 grams. Okay. So remember the different twisting or doing the somersault for the Fe, no? So I'm placing here, in the first one, I'm dividing the molar mass to get the moles. But now, I'm multiplying the molar mass in this part to get the grams. Okay, so please take note of that mathematical operation. Okay. The answer for this one is, okay, I'll give you the chance to answer everything there. So we have 150 times 1 over 159.69 times 2 over 1 times 55.85. Pause the video if you want to calculate everything on your own. Okay, so assuming that you're done, or assuming that you have paused the video, the answer is 105 grams. Okay, so take note that I'm still using 3 significant figures because the initial value is 150 grams and it's 3 significant figures. Okay, alright. So that's it. That's our theoretical yield. The second question asks or requires us to determine the percent yield if the given actual yield is 87.9. Okay. Take note that your actual yield should always be lesser than the theoretical yield. The reason being is that when you talk about actual yield, you actually got that value by weighing the amount of substance that you're getting. So of course, in reality class, you will not get the chemical reaction. You will not expect the chemical reaction to undergo completion. So expect that a portion of the reactants are not fully converted. And also, when you perform actual experiments, you will be experiencing some losses in amounts because some particles may stick to the apparatuses, or there might be some accidental weighing with respect to the human error. So those are some factors affecting the value of the actual yield. So it should not exceed the theoretical yield. Okay, it should be less than or equal to the theoretical yield if possible. So we have here actual yield of 87.9. Oops. 87.9 grams of Fe. And our theoretical yield, okay, from what I can remember, is 105 grams. Okay. So the question asks for the percent yield. Okay, so remember that there is an equation relating the three. Percent yield is equal to the actual yield over the theoretical yield. The theoretical yield. Okay. Multiplied by 100. Okay. So I think this is easy in this part. You just need to plug in the values. 87.9 grams of Fe. 105 grams of Fe. And then multiply it by 100. Okay. Pause the video if you want to answer by yourself. Okay, so the answer for this one is you have 83.7%. Okay, so what does this mean? What does a percent yield of 83.7% mean? So if I'm going to make a statement out of this, you can say that for every 100 grams of Fe. So from where did I get the word 100? Where did I get 100 grams? Percent. The meaning of percent is per 100. So for every 100 grams of Fe, that can be be obtained okay, am I writing it correctly? That can be possibly obtained. Okay. And then you can only acquire or get 83.7 grams of it. Okay. So of course, that 83.7% is influenced by a lot of factors. So it may be the process was not well done, or yeah, there might be some factors in the extraction of the material. Okay, so the study or the endeavor of improving the yield is another field of study in itself. Okay, so it's good that at this level you will be able to experience what it's like to solve for the percent yield based on the values of the actual and theoretical yield. Okay, so I guess that's it for our Ask Teacher J video on theoretical yield. I hope you learned something today, and I hope to see you in my other videos. See you next time and have a great day. Goodbye.